all of the research that we've done from the metabolic lab students have been involved, both undergraduate and graduate students. And then some of the studies have been in underserved populations, such as African Americans, Hispanics, and South Asians like myself. So I just want to talk briefly about the types of studies that we've done. And the main area really is looking at the effects of dietary and exercise interventions on cardiovascular risk factors such as lipids and lipoproteins, glycemic control, and all the hormones that control blood glucose, blood pressure, and FMD. FMD is a measure of endothelial dysfunction, and body weight. So those are the areas that we've looked at as far as cardiovascular risk factors are concerned. And then in addition to that, we've looked at the effects of diet composition, like a high protein diet or a high fat diet, and how that affects satiety ratings as well as appetite hormones. And then we also looked at the effects of eating speed on not just energy intake, but also satiety ratings and appetite hormones. And then we've looked at the effects of menu labeling on food choices and nutrient intakes. Now, I want to speak a little bit more about our recent study, which we had to stop in mid-March. And this is where we were looking at the effects of a ketogenic diet versus a high carbohydrate diet on performance in highly trained athletes. So I think many of you may know that a ketogenic diet is an extremely low carbohydrate diet and very high in fat. And it's become quite popular in the US, and some of our athletes are also consuming it. So we wanted to look at how a ketogenic compared to a very high carbohydrate diet, which is what athletes used to traditionally consume to help with performance, to see if there are any differences in performance between the two diets. Now, in addition to that, we were also looking at the effects of these two diets on lipids and lipoproteins, glycemic control, energy expenditure, hormones that affect satiety and hunger, and a few other things. So it's actually quite a big study where we're looking at many different outcome variables. And I want to point out that this study, we had 3 PhD students collecting data for their PhD dissertation, as well as master's students and undergraduate students. And then several faculty have collaborated or are collaborating on this project. And we're hoping to pick this project back up as soon as we're allowed to have outside subjects. So anyways, I just hope that what I said is of interest to some of you, and I'm hoping that some of you will be interested in collaborating with us, and just feel free to contact us if you're interested. And thank you for giving me the time to talk about this lab and the work that's come out of this. Thanks, Emily, and thanks everyone.
Slide.
Okay, hey everybody, my name is Andy Kreutzer. I'm the lab coordinator over in kinesiology, also third-year PhD, and I was one of the ones involved in that large cycling study, so I'll talk a little bit more about that later. We've got a little video going that's showing our exercise physiology lab upstairs, and we'll show some of our other lab spaces as we're going on. And I was going to start with the equipment first because, you know, the interest might be in what other equipment can people use to collaborate. So we have a lot of exercise equipment, obviously, since we're in the kinesiology department: treadmills, cycle ergometers, resistance training equipment. We do, at very first in this video, you saw the environmental chamber, so we can test in hot and cold environments. We've mainly used it for hot, but we could also do cold environments if we wanted to. We have metabolic and cardiovascular measurement devices, so we can measure oxygen consumption, energy expenditure, and, you know, carbohydrate oxidation, fat oxidation, those kinds of things. And then we have an ECG system that's fairly new, that's set up for exercise testing, so we can test people at different levels of exercise with the full lead, 12 lead ECG if we want to. We have 2 field testing systems that are both catapult GPS systems that have GPS units and accelerometers, gyrometers, where we can track distance that athletes run on the field, and one's for outdoor, one's for indoor. So we've used it with the TCU soccer team, and they're actually using it this year again. And we've used it with some basketball teams, not the TCU one, but some other basketball teams. So lots of interesting data coming out of that. We do have the DEXA unit that's housed in the Physical Activity and Developmental Disabilities Lab that allows us to do bone densitometry and body composition. So we can look at bone mineral density and percent body fat, percent lean muscle mass, those kinds of things. We also have 2 ultrasound systems. One of them can be used for musculoskeletal measurements. So we're looking at muscle thickness, cross-sectional area, those kinds of things. And we can also, we're trying to kind of validate that as part of the cycling study. There's a company that offers us to analyze kind of relative glycogen storage in the muscle using the ultrasound. So that's based on the ultrasound pixel intensity, and will tell us pretty much how much water is in the muscle. The dark that will then allow us to estimate, because we know approximately how much glycogen is stored along with the water, that will allow us to estimate how much glycogen is present. There are some issues that other labs have brought up with the system, so we're trying to validate if that works for our application, because it's really an acute measurement for us based on exercise, more so than kind of a chronic measurement based on diet, where other people have seen some issues with the measurements. We also have another ultrasound system that's set up for cardiovascular measurements, so we've mainly used it for flow mediated dilation, so artery diameter and the changes of that. And so that's something that's always available to kind of give us an idea of vascular health. And we could do images of the heart as well. We have not in the past, but we're set up with that system to do that. And then we have a fairly large biochemistry area where we have a flow cytometer where we can label cells and measure individual cell types in assays. We have a multimode microplate reader that's pretty new, that pretty much has all different reading modalities, from absorbance to fluorescence intensity. We can also do nucleotide analysis there, where we can, figure out DNA concentration, RNA concentration, those kinds of things. And we have a multi-beat based multiplex analysis system where we, in the past, have looked at cytokines and hormone levels, and we can run, because it's a multiplex system, we can run, several variables at the same time. So we've run 10 to 12 plexes where we can run 10 to 12 different cytokines, for example, at the same time in one plate. And we have I think you saw that in the video, a hematology analyzer where we get just a typical regular complete blood count and white blood cell differential analysis. So in terms of our research that we do, on the next slide,
I'm sorry, on the next slide, do you want me to click forward?
Yes, please. Sorry. So for the exercise physiology labs, same thing, very multidisciplinary. We've worked with researchers across Harris College and outside of Harris College as well. Very student driven as well, with master's and PhD students and undergrads involved in just about every study that we do, just because they're extremely helpful. We need the hands, we need the ideas, we need everybody to collaborate. Big research areas are thermoregulation and the effect of heat on exercise responses, exercise immunology, sport performance and athlete health. We've done several studies into concussions before, and then with our new exercise physiology faculty, Ryan Porter and Josh Carr. There's going to be an increased emphasis on physical activity and chronic disease risk and neuromuscular physiology. The current studies, we have that ketogenic versus high carbohydrate diet that Mina was talking about earlier. That's been a really large study. I think from I would say from an equipment perspective, what's kind of interesting on that is that we allow people to bring their own bikes, and we have 2 cycle ergometers. They're bicycle trainers, but that can measure power output at a lab research type level, where they can bring their own bikes, strap them into the ergometer, and not have that training effect or that getting used to the equipment effect that we usually see. So they can bring their own bikes and ride them like they're used to. And then we're also currently working, again, multidisciplinary, on an endurance athlete survey, where we're asking them about their habits and kind of perceptions of a variety of different modalities, be that training, nutrition, supplement use, sleep, recovery modalities, all kinds of different things, to see how endurance athletes actually do the things that they're learning from research, because there's lots of research into all these areas, but we don't really know how athletes actually implement those strategies in real life, and if they adapt them, if they have to adapt them, or if they can actually follow them the way they're tested and presented in lab studies. I've got one more slide that I'm going to talk about. That's Dr. Esposito, Phil Esposito's lab. That's the Physical Activity and Developmental Disabilities Research Lab. That's where the DEXA is housed. And again, in that lab, we do lots of student research or student-driven research. Students consistently present at physical therapy and OT conferences, and the main research areas are health disparities in individuals with intellectual and developmental disabilities, and then interventions and programs to decrease health and motor deficits in people with intellectual and developmental disabilities. A couple of recent studies looked at adaptive skills and school readiness in preschool children with Down syndrome, and at the relationships between strength and balance in adults with intellectual and developmental disabilities. And that lab, on a regular basis, takes students to the Special Olympics to do testing there, which is always a great experience for student researchers to kind of get that direct application and the direct interaction with the Special Olympics athletes there.
All right. Hi, everyone. I am Robin Trocchio, and I'm representing the Sport and Exercise Psychology Lab in the Kinesiology Department. And our overall goal within this lab is really to look at the psychological factors that are associated with participating and performing within sport, exercise, and other achievement-oriented activities. And really, this lab is looking at taking this scientific information, putting it into professional practice, and then vice versa backwards. So within here, we are looking at examining perceived effort and using that psychophysiological perspective. So again, like both Mina and Andy were discussing, using this multidisciplinary approach. So looking at how the mind and body work together. So how our attention and our focus impacts our perceptions of effort and how this can influence exercise adherence. Also, we do a variety of applied sports psychology research projects. So as they were mentioning about the endurance or looking at the keto versus high carb diets, I was a part of that study as well, and hoping we can get going again at some point. But my part of it was looking at how these diets impact our mood and our cognitive function. So as you can see in this picture here, these are my grad students demonstrating it, but using the Stroop task to really see and look at that executive function and see how pre a time trial to post, how that impacts cognitive function and mood, and how the different diets are impacted. So that was one of the applied studies. Another study that we have going on, one of my thesis students is looking at how virtual reality or relaxation training can impact the performance of a penalty kick in soccer. and combining that using the information that Adam will be talking about in a minute to look at, see, okay, what happens if they do a relaxation training in that performance. On the next slides, I'm going to have my grad students demonstrate one of the studies. Fingers crossed this works.
The purpose of this study is to investigate the individual's perception of exertion and attention allocation during an exertive stepping task. While the individual is doing the stepping task, we will have them call out their attention and RPE every 30 seconds. Afterwards, we will look at the differences between fit and unfit populations in their stepping task performances, as well as looking at the differences in individuals that knew their heart rate while doing it versus non-knowledge of heart rate and where their attention was during the stepping task.
All right, so as you can see here, we have a weighted vest. So for this study, it's actually 20% of their body weight. So a lot of weight on them, but able to do it, step up and down and go as long as they can. So we have heart rate monitors, as well as you can see that little stepper there. So on the next slide, you're going to see another one of the studies we have going on.
The purpose of this study is to examine virtual reality and the effects of exercising at an intensity that feels good for the individual, as well as enjoyment in a rowing exercise for 4 weeks. There will be 3 different settings. One will be nothing on the screen while they're rowing. The second will be virtual reality just on the screen monitor. And then the third one will be a 3D headset with virtual reality. Afterwards, we will look at the effects of the 3 different settings on perceived enjoyment and performance outcomes over the 4-week training protocol.
All right, so as you can see in this video, this is one of our newest pieces of equipment, and I have to give a shout out to RCAF for funding this. So this allows us to use different types of virtual reality to look at and see how this can impact exercise. So we're looking forward to continuing to use this equipment, and we always involve students at all levels in our research. And if you're looking to collaborate, I'd love to work and expand our team. Thank you.
The purpose of
I'm up next, right? All right. So welcome everyone. My name is Adam King. I'm leading the activities that are going on in the motor behavior lab, and going to give you a virtual tour of some of the things that we've got going on for our activities. As we're looking here, sorry, just a second. Not just at me, don't worry, there's more than just me going on in here. So we've got a motion capture system that is up around the room. So there's some cameras up at the corners of there that we're going to use to capture movement within here. That blue square in the middle there is a force plate that allows us to be able to measure some ground reaction forces and to be able to analyze some center of pressure sway aspects. So most of what we've got going on in the lab and it either uses the motion capture equipment, uses some form of the force plate to be able to measure muscle activity, or sorry, to measure kinetic forces, and then we also have some sensors that allow us to record muscle activity. When we look at motion capture, one of the cool things that we use often are these reflective markers that we place all over the body, and when we collect data like this standing long jump, we put a bunch of them on an individual, and we can record the kinematics and motions that are happening during this jump activity. So this is a project that's been worked on through a few different semesters for both undergrad and some grad students, looking at how jump performances might be changed by where we direct our attention. And so we looked at several different kinematic properties within that activity to see how the biomechanics of that can change. So that's one project that's been going on. when we use our motion capture, something else that we've been able to use in a sport activity is looking at some baseball pitchers. So we've used some of the players here at TCU and ended up putting a lot more markers on them, about 54 across the entire body. But if you're keen enough, you can kind of identify that that is a right-handed pitcher that's throwing a fastball down here in the lab. So we collect data from them and partner with a group to be able to look at some injury risk measurements up there. So anything that you wanted to look at from a movement or a motion standpoint, we focused largely on some large or whole body movements, but simple tasks of reaching and grasping are other things that can be done within the lab as well. The other equipment that we've incorporated in here is our wireless EMG system. And so Dr. Trocchio mentioned about using these for the soccer players to look at their relaxation methods. And then these allow us to record muscle activity as well as motion characteristics that are happening when they are performing the task of that. When we start to look at aspects of our skills that we're looking at, again, we're trying to focus on skill performances, both from a sports standpoint, but as well as from an injury standpoint, and how we can regain their performance levels back to a competition or return to sports standpoint. So we're focusing our studies right now on some postural control activities and with standing balance and looking at how people can perform that in a pre and post fatigue state. So we've got an honor student who's putting individuals through a fatiguing task and then measuring balance prior to previous pre-fatigue and post-fatigue to see how balance is affected for that. And then we're also looking at a training design with our broad jump task to see how individuals can learn to perform that task in a more skillful manner by using a couple different training methods. Again, a lot of things that we're looking at are movement-based. So if there's anything that you see that can be incorporated into your research or ideas that kind of pop up into our realm, would be more than welcome to have some conversation and kind of brainstorm some ideas. But that's what's going on down here in the motor behavior lab. So thank you.
Thank you. And now I'm going to hand the presentation over to Dr. Cheek and let him share his presentation. Oh, and you might be on mute.
Myself. Now, can you see it okay? And like anything, I have to put the disclosure because, of course, we have all the supply and equipment. So first thing I need to do is let you know that I'm not endorsing anybody here, using everything. And again, so no conflict. So I just want to make sure of that. So let me introduce you to the Nursing Research Laboratory. It's located on the second floor of Bass Building, Bass 2212. And having been here, I've had the opportunity to collaborate a lot with kinesiology, nursing, nurse anesthesia, psychology, chemistry, and the latest one now is, again, nutrition with Dr. Jada Willis, who is in the lab now, also contributing. So if you haven't had a chance to come visit the lab, you are more than welcome. Just give me a holler, and let me show you what we have that is available to you. As you come in, of course, we have a BSL for cell culture with the incubator there. And the first thing I want you to take note of is that big yellow speed vac. It's a new piece of equipment, and a shout out to, again, Dr. Chris Watts, our dean, for support. Speed vac allows us to separate with a centrifuge, a pump, and basically a collecting to remove methanol from any of your samples, which is nice. And so I'll come back to why it's important. Inverted microscope, and then again, on the back, we have a -80, -20, and standard refrigerator, freezer fridge, and equipment. Again, a refrigerated centrifuge. And we have a plate reader, but we only can do 8 absorbances, so we don't have the multimodal stuff like Kines, so we go over there if you need to use. but it do fluorescence and luminometer. The second new piece of equipment is the BioRad plate reader, which can allow to do Western blots and gel technology and capture it. If you get interested in molecular, you want to capture proteins and separate them and then capture them and analyze them. And that was another piece of new equipment. And now we get more to the molecular side, again, set up for doing PCR. We have a thermal cycler and both a refrigerated, unrefrigerated, small centrifuge. And in the corner, again, is the a RT-PCR device. So if you want to do real-time PCR, and the nano drop, so you can calculate, again, how much protein or how much RNA, DNA you have, or protein if you want. And again, room for students or those visiting. And then the big screen, which we of course did the FMD work. But I want you to take note of the little device in the corner here. It's blue, it's called a Bendy 2, which I'm going to talk about the Bendy 2 because that probably may be of interest to you. So first area of research, of course, is women and heart disease. No matter what anybody's saying and COVID around, heart disease is still the #1 killer of men and women. Okay, COVID just happens to be in the front line, but what we're looking at is kind of the effect because of estrogen. It's protective, and so we look at vascular reactivity. We were using the FMD parameters, but the FMD is very technical, have to be savvy, you have to do a lot of them. So what I've found was what's called the Bendy 2. And basically it requires just a blood pressure cuff and 2 finger probes, non-invasive, and in essence, it will do FMD by temperature change. And it's portable, it'll go wherever you want, and all you need to do is have them sitting in position, and it takes a total of 15 minutes. So we're using the Bendy 2 now, and we're going to start back up. And our interest now is looking at the effects of diabetes type 1, since we see a lot more of them. And a lot of the students that we have now, of course, have both the implanted device for monitoring sugars and their app on their phone. And so now we're looking comparison of those without diabetes and those who have diabetes on their vascular function. And the Bendy 2 is a great device. And like I said, it travels. So again, if it's something that's interest to you, and again, I always make it research proof, which means you can't mess it up, okay? You can't mess it up as researchers. So when we have students that are using it, they can't mess it up either. So first area we're continuing with. Second area, of course, is working with Ann Johnson and Lisa Bayshore and others. And they were looking at salivary melatonin and cortisol, which we've all done, both in blood. We've done a lot of salivary cortisol. But what's intriguing and what we've gone to now is that SpeedVac is why we got it. We have the plate reader. We are now measuring hair cortisol. Hair cortisol, which is a real simple, and now because of COVID, we had to get away from trying to collect the hair. So now the person can do their basically 1-inch clip of their hair, put it on aluminum foil, stick it in the mail, comes in, and that's it. That's storage. That's all that's required. Room temperature, it's forever. Then we extract cortisol, and the cortisol, which becomes interesting, is it's a 90-day average. Okay, so you have to do it longitudinally, but there's no set for it, but there's a 90-day average of the cortisol in the hair, and you only need 1 inch of it, very small part. So again, is that something that's interest to you? We use the same kits that are used for salivary, but we have to extract the cortisol from the hair, which is why the SpeedVac is there. And we've been doing it now, got some great results. And where we're using it now, the study we're doing now is looking at nursing students and stress. So you might have some students that might want to be checked for stress if they're interested, or you may want to check for stress, or maybe the faculty's test for stress. So longitudinally, so that's a second area of interest. The third area is, second or third, is looking at your pharmacology and your genetic makeup, or pharmacogenomics is what it's called. And a lot of it is data that a lot of people are getting from 23andMe, Heritage, Family, you name it. And now what we're looking at is the makeup of the CYP enzymes in the liver, either by report or by, again, the information they share. about the drugs that they shouldn't be taking. And our first study we completed, myself and then Michelle White, who is now one of our now returned to graduate school here at TCU to complete her DMP and psych mental health. We were looking at pharmacogenomics in psych mental health and basically trying to see if there was a way to adjust meds. Not we were doing it, but the provider was. And what we found is that when they used pharmacogenomic testing, the drugs were adjusted, and there was 100% change with a reduction in any adverse drug reactions and improvement on efficacy. Because one of the side effects with all mental health drugs is side effects. So that is where I'm at. I'm going to turn it back over, but you are, again, more than welcome to, again, give me a holler. I'm in the Bass building. On the second floor, on the same, my lab is on one side. I'm in the office on the other side in 2232. And you can find me an email. And again, have collaborated, as Dr. Shaw mentioned, lots with kinesiology, lots with psych, lots with nursing, nurse anesthesia, now nutrition, chemistry. So again, that's the one thing I like about the small school is a lot of, again, collaborative nature, both in the student and faculty. So I'll stop there.
Very much. So the last two labs that we're going to present today, one is Dr. Julia's lab from COSD. She couldn't be here today because she is engaged otherwise in research. So she sent me some slides to represent her. And then I'm also going to have Dr. Rivero Campos present on his equipment that he has in his lab as well. And of course, in these presentations, we recognize that there are many, many researchers across the college that are doing really cool work that is not equipment heavy. But it seems like a reasonable starting point to talk about those labs that do have equipment to start thinking about what collaborative opportunities we have. So Dr. Julia is the principal investigator of the LASER laboratory, the Laboratory of Applied Swallowing Research. Her focus to date has been on COPD and the coordination of breathing and swallowing in patients with COPD. She's also been thinking about early identification of dysphagia, so issues with swallowing and COPD, and efficacious dysphagia treatments and optimal dosing across various participants. So in particular, she has been thinking about tongue strength and the effects of mental practice on some of our populations as they try to adjust their swallowing patterns to deal with some type of aging or disability. Some of the equipment that she has in her lab includes pharyngeal manometry, and this measures pressure changes in the pharynx and the opening of the esophagus during swallowing. She is able to engage in surface electromyography, so muscle contraction, patterning, and timing. And specifically, she thinks about, as you see in some of these pictures, the muscles related to swallowing, so very small muscle movements, but very, very important ones. She's engaged in accelerometry, so looking at acceleration forces or vibrations related to speech, voice, and swallowing. And she has capacity to perform flexible fiber optic endoscopy. I usually don't have to use these words in my job, so I'm having to think while I say them. So she engages in high definition imaging for visual analysis of pharyngeal structure and function. So if you have interest in issues of feeding and swallowing dysphagia, Dr. Julia has a really great lab setup that can help you think about some of these things. She also has access to respiratory measurements, so spirometry, looking at airflow and volume, and respiratory inductive plethysmography. She measures lung volume, rib cage, and abdominal band excursions, and it is calibrated with known volume from the spirometer. So she's able to think about, again, in that line of research that she does, the coordination between your breathing and your swallowing as you try to go through this process of eating. And so you can see here some cool things, especially here in the middle from Dr. Drulia's lab, where she thinks about how our patients swallow, eat safely. And then I will turn this over to Dr. Rivera Campos to tell us about the BEST lab.
Hi, hi everybody. My name is Ahmed Rivera Campos. I'm from the COSD. My lab is called the Biofeedback Education for Speech Treatment. It took me a while to look for a lab name that will kind of sound good when you put the acronym, so that's why it's called BEST. So yeah, we can move on to the next slide. So the purpose of my lab is to educate students and professionals in the use of biofeedback technology when it comes to speech sound production. So for example, we use ultrasound imaging, and we also use electropalatography. For the lab's area of research, we are currently looking into the effectiveness of ultrasound biofeedback in disordered populations, as well as individuals who are learning more than one language and they come across particular speech sounds that are not shared between their main language and the second language, and they're having a hard time producing those. And we're also interested in which are the best practices for training school as a speech language pathologist or teachers of foreign language, or I should say pronunciation teachers, when it comes to teaching them how to use these particular technologies, either for remediation of speech sound errors or for just or as a pedagogical tool. We can move on to the next slide. Currently, I have 5 portable ultrasound scanners. All you have to do is just hook them up to a laptop and install the software, and then that's it. And I also have 2 portable wireless ultrasound scanners that all you have to do is just install the software to a smartphone or a tablet, and then you'll be ready to go. Next slide. For electropalatography, we only have 1 equipment so far. It's portable. The only thing you need to do is install the software and just hook it up to your laptop, and then that's it. In the event, you might be asking yourself, what is electropalatography? So it is a system where we have to create a false palate. Then you put it on your hard palate, and then depending on your speech sound production, specific sensors will light up. And based on that information, you can have information that you can then use to teach the person on what changes they need to do regarding their tongue shape for speech production. Next slide. And yeah, for collaboration, or something later on sparks your interest, we're interested in the intersectionality between speech and production and other health-related areas, and also for best practices for teaching professionals on how to use biofeedback technologies. And that is all.
Okay. So here, before we go into discussion, I'll stop sharing the screen, but I wanted to remind everybody that the next Faculty Research Symposium is Friday, October 23rd. And now I'd like to open up the floor to questions that people might have for all of our speakers today, or perhaps ideas that you have for collaboration across the college.
I have a question for Dr. Cheek. So you can see me ask this question. Hey, Dr. Cheek, the cortisol measures that you take,
Okay.
are they sensitive enough to detect acute changes in cortisol? For example, you take a measure before some task, and then the individual does some stressful physical task for 30 minutes of some type. Are there measurements with your equipment that would be sensitive to any changes over that short period of time?
Well, the short period of time, unfortunately, would probably be more the salivary or blood. The hair, unfortunately, the best that can be done is we know that hair grows at a certain length. So we know that basically the first centimeter will be the last 30 days, the second would be 60, and third would be, again, the 90-day period. And that's the most you take is about 3 centimeters or just over 1 inch. They're going to be more, again, an average. So it will pick up the changes, but it will be averaged in. So in your question, sorry, no, it won't pick up that acute difference. The salivary would be the one to go with that. And there's actually a more sensitive, not cortisol related, but there's one that follows the sympathetic system that you can do salivary wise that would note the change because it follows norepinephrine that you'd probably want to look at, but you can get both salivary cortisol and salivary, the second enzyme that follows the sympathetic system for the acute change.
Yeah, because there are some issues with the salivary cortisol and its stability, right? So
yep,
this other measure from saliva may be a more stable.
The hair is nice because it is stable, and you, like I said, it can be done when sent in. It's just taped to foil. It can be forever at room temp. It doesn't have to be stored like, again, and as long as they got the cut from it, it doesn't affect on across the board in regard to race, because it's done, it has been done throughout in race, so it's pretty a standard. So it's starting to get more and more of that.
Thank you.
If I could jump in on the cortisol real quick, we've done salivary cortisol measurements from blood and also urinary. So we definitely have the capability if that's of interest, and those would then be indicative of more acute changes that we then just, it becomes a storage issue. We have to make sure they're stored correctly and not too long. But you know, we've successfully done it in the past, and we can do it with the microplate reader without a problem.
Yep.
So how sensitive would those blood-derived measures or urine-derived measures be to very modest physical activity? That is, if someone is speaking, for example, and the only thing that's really moving are their speech muscles, would you be able to detect changes with that minimal amount of kind of muscle activity compared to some of these big movements that you may do in your lab, Andy?
Right, we've always done bigger movements, so I'm not sure. I could look into that for sure and see if anything's been done on that. The things we've done, you know, whole body movements, those kinds of things. We've also looked at, you know, stress at different time points in the semester. That was just kind of baseline stress responses based on cortisol, where there was no physical activity involved. But if we're trying to look at something acute with these small movements, I'd have to look into that some more.
Yeah, we'd love to help you there, Dr. Watts. If you got somebody with saliva for small movements that, you know, Andy and I can assist you with.
I'll be in touch, definitely.
I have a question for Dennis. So you've done work in the area of sleep and cortisol. Have you measured melatonin by any chance?
We are, am I off? Okay, I'm off, good. We have just started working with Ann Johnson and Lisa Bayshore, and that poster that they put up, which they presented the work on, they actually got salivary measures from Cook Children's cancer survivors, and they were actually, which was nice, they actually collected it before the student, or before the participant went into a sleep study. So we got melatonin before they went, and melatonin and cortisol before they went to sleep. They did their sleep study, and then they got the melatonin and cortisol after the sleep study. So we got a before and after when they were getting their sleep study done at Cook Children's Hospital. And so, yes, we have measured melatonin. We have measured the cortisol salivary wise.
Can I ask one more question? So with the
Sure.
diets that we're doing, interventions, each diet is consumed for 2 weeks. Can you actually see a change in melatonin if there is going to be a change?
We should be able to detect the change. And again, we're happy to, again, it's just, again, what we're using is a salmetric kit that's all prepared and set up. So again, be interested in running it and finding out the answer.
Okay, thank you.
So I got a quick question on just clarification for Dr. Cheek as well on your popular guy today.
Okay, I'm happy to share. It's one of those things that we all collaborate and we all have parts. So go right ahead there, Ryan.
Yeah, we're all over this cortisol stuff. So on the hair sample that you're collecting, so is that coming from the end of the hair, or are you getting the sample down by the root? I would imagine you need it down by the root, correct?
You got it. So basically, it's, again, everybody, it's accepted in literature that basically hair will grow a centimeter a month. So you're right. We get it from the base next to the skull, and you go out basically just 1 inch. You don't have to get a big chunk, so you don't leave a spot, but you just come out 1 inch. And we were originally collecting it from them by basically you just make a little tie off, you cut at the base there, you don't get the root, so you don't get any genetic material, which is a part that everybody gets concerned about. We don't get genetic material, so we're not running DNA or running RNA. It's just from the base of the skull up. About once again, 3 centimeters or about a little bit more than 1 inch, okay, because it's 2.5 centimeters is an inch, so just a little bit more of an inch. And as soon as you get it, all you have to do is tape it down and let us know where the root began, because we will measure just 3 centimeters and cut there and put that to extract. Any further, it tends to get to a washout, which is why you don't go any further than that. It tends to wash out. But the first 3 centimeters, so if we wanted to go 1 centimeter, if you could get it, that's the last 30 days, 2 is 60, and 3 is the last 90. And so from the base there, and that's it. And that's the part. That's, again, it's kind of nice now because as an indicator, the variability is already taken into account, but it'll be 90 days previous. So that's the problem. It's more of a longitudinal falling.
Great, thank you.
I have another question about, I don't know if Adam's still on the call, but Ryan, was it you who was getting the Trino system, or was that Josh? Mina, which one of your faculty? You're on mute.
That's Josh.
Okay, so are Josh and Adam collaborating in any way? I know that I had started to use, and Teresa, I believe, is using a similar Trino system in COSD. So now we have 2 separate lab groups, if you would, that are using similar methodology. I don't know if maybe there's a collaborative idea there between these 2 different labs and 2 different departments. But I don't
Yeah,
think
Josh and I have started some conversations on what collaboration opportunities there are. One of his grad students working with some of our data that we previously collected, but yeah, both of us have some EMG technologies, and I think looking across the departments, that are in the college, and that might be a good, I don't know, maybe it's a center, a idea that can be brought out of kind of shared knowledge around muscle physiology in different aspects of speech and movement and those kind of things. But that would be a common ground to see with that going on from what we heard today.
Yeah, Adam, you are ready for Halloween, obviously. But you measure the big muscle groups, right, with your EMG?
Yeah, large muscle groups, surface muscles that we have easy access to by just placing the sensor on the scan. Nothing deep in that or anything too small that we might not be able to get direct access to.
Okay, thank you.
Robin, I have a thought about some of your equipment. I don't know if there's a question embedded here, but a possibility for something to look at. So something we are exploring in my work with children with hearing loss is whether or not yoga improves things like executive function, especially during telehealth sessions. It sounds like you've focused a little bit on this, on some cognitive functions following exercise. Have you done work or thought about like how rigorous the exercise needs to be to have an impact on cognition?
I personally haven't researched it, but I know based upon literature that the higher intensity and based upon this study too, just we only have 5 participants, but looking at it, it actually decreases. So that high intensity actually causes it to go down. So if you're going to do high intensity exercise, don't do it right before you come to work, because then your cognitive function's down. So actually doing that moderate intensity tends to be the best.
So do you think there would be a possibility if, say, this summer COVID restrictions are relaxed and we're bringing 60 kids with cochlear implants to TCU, that there could be a study where we could look at varying degrees of physical intensity and an effect for kids with hearing loss?
Absolutely. Yeah, we could figure it out and design something. I think that'd be really interesting.
Just to give a thought on that, we're doing that out in the link schools right now, and we're not measuring the impact of it, but we are using breathing techniques and being in a particular area of the room when they come back from recess to bring them back down off of that high amped moving around. And it definitely does that. And for kids who have a lot of frustration or anger or just emotional episodes, it has been huge for them. So
Well,
I think that'd be a great study.
Cool. And to link in some of what Dr. Cheek was talking about, there's been a lot of discussion in the literature about chronic fatigue in our kids with hearing loss as a result of listening effort. So all of these things are making me think a lot more about.
Let me tell you, I can tell you about it, the fatigue when I went to Finland and was trying to understand people in another language. That was fatiguing. And so, yes, I feel what you're talking about when I went to Finland. That was, oh my gosh. Every afternoon around 3, I'd have to take a nap because, at least the first week, because it was so emotionally draining. Yep. Hey, Dr. Cheek.
Right here.
Do you want to talk about what the expense might be to do the hair testing?
So, because I've, again, been working with others a part of this. So the biggest expense for doing the hair cortisol is the kit. And the kit's a standard plate, 96 wells. 16 wells are taken up for the standard and a high-low control. So you can get approximately 40 samples done in duplicate. And so that's the biggest expense. The other expense that comes in then is basically if the person's doing their own, basically picking up the hair, it's just a small snip, scissors, and a comb, and again, cutting, and then putting it onto aluminum foil, which again, most have. And then now we have it getting in by mail, standard mail-in, a stamp, 41 cents. That's what it is. And again, can be mailed, and the storage is, plenty. It just needs to sit somewhere. So when we're looking for research and you're doing it, then it's again, and there's video again available about how to actually collect it. So, it's one of those things that's kind of nice. We started originally by having it collect at specific sites, like here on campus. But when COVID came, Ann Johnson and Shirley, actually, there's a video they made about how you collect it, and the participant just looks at it and said, oh, I can do that. Basically, they're giving themselves a small little snippet in the back. They're not taking a big chunk, but it's got to be basically, small. It doesn't have to be a lot of hair. It's again a small, no larger than a pencil size or even smaller than that sent in. And so, like I said, the biggest cost is the kit. And again, that will do 40 samples in duplicate from from those. So that's the biggest cost of everything. So it's kind of reasonable. And like I said,
You remember how much that is?
I think the last time we took a look, it was somewhere around the 275, 300 range for plate, $300 for the plate. Because again, we were running again, because when it comes in the lab, either myself or an RA I have in the lab, we do all the work. And the RA that's in my lab in nursing is covered. So it's again, not expense to anybody else. It's just, again, you get the kit. If you purchase a kit for that 275 or 300 range, if you get more interested, give me a holler and I'll get the specifics for you. Or the videotapes about how to cut your own hair.
All right, well, if we don't have more questions, we'll end 10 minutes early. I guess maybe that's the amount of time that lunch takes up. Is that right? Maybe a little bit more. Thank you all for coming, and I hope to see you again for our October Faculty Research Symposium. Thanks, everybody.
Thank you. Thanks, Emily.
Thanks.